Hey, this is Zachary Walker-Liang. This is my final project for Mike Shaw's computer graphics class at Northeastern University. So this is my implementation of a halftone shader. We can see here that we're using a simple two-tone cell shading technique, and on top of that we're also using these dots to convey which areas are brighter and which areas are darker, and they dynamically change depending on where this point light is. These dots are actually defined in texture space, so each one of these objects are UV unwrapped, and we can lay over this procedural dots texture using some math that we'll get into later to decide where the dot should be, and then the radius of the dots is also calculated. We can also see that there's a shadow here that's implemented. It's a simple directional shadow, and this directional shadow is just following the light here, so it looks like the light is casting the shadow. Here's another object here, which is just a plane, and this shows that we can just have two objects that are both casting shadows in the scene, which is pretty cool. So one other thing to point out is that this shadow here actually doesn't change the color of the fragments at all. It just changes the radius of the dots. You can see that the shadows of this chalice here, it's increasing the radius of the dots, but the actual fragment color doesn't change, which is pretty cool. So one thing to note here is that the shadow light is actually decoupled from the light in the scene. So this point light is rotating around, as we can see here, and this is the shadow from the chalice here. I did this because there are a lot of times where I might want multiple point lights, but only want one thing casting a shadow because of performance reasons. This is an idea that I got from the game Hi-Fi Rush. And here's a demo of the unshaded raw shadows for this scene. Most of the magic in this project happens inside of the fragment shader. The first thing we do is we calculate how much light is hitting this fragment. The next step of the fragment shader is calculating the radius of the dot that the fragment is closest to. The radius of the dot is directly proportional to the amount of light hitting this fragment, and it also has to do with the ruling if this fragment is in a shadow or not. So if the fragment is in a shadow, we'll return the maximum dot radius. Otherwise, it is just proportional to how much light is hitting the fragment. The next step of the fragment shader is actually a pretty important one. We are actually going to generate that dot lattice structure that you see on each of the objects. It's this isFrag and dot. And what we basically do for each fragment is we find the distance between it, so each fragment, and the nearest dot. And this is all done with math. There's actually no images being passed, no dot images being passed to OpenGL. We just calculate, depending on the distance between the dots, how close the closest dot is to each fragment. And depending on that and the radius of the dot, we know whether we are inside the dot or not. So finally, at the end of this fragment shader here, this is just the calculation for the two-tone cell shading that we have in the project. It just takes the amount of light that hits the fragment, and if it's below a certain threshold, it just subtracts a certain number off of the ending color. Thanks for watching. Let me know if you have any questions. It was a lot of fun to make this, and I'll probably keep developing this in the future and probably implement it in Unity for some games that I'm making.